Hey guys, welcome to the worked answers for the 2018 Day 1 MCAT exam paper. Let's get into it. So, question 1. The sides of a rectangle are 2x plus 3 and x minus 2. Give an expression for the area of the rectangle in the form ax squared plus bx plus c. So we can even draw this situation. We've got our rectangle, sides of 2x plus 3 and x minus 2, and we're looking for the area. So we know the area of a rectangle is base times height, meaning we can just substitute in our two values because we've been given base times height. So our base is 2x plus 3, and that's in brackets, and our height is x minus 2. Okay, it's not enough to leave in factorized form. We actually have to expand these brackets, and what I mean by that is using the FOIL method. So we're multiplying first, outer, and then inner, and last. Okay, so 2x times x is 2x squared. 2x times negative 2 is negative 4x plus 3x, and 3 times negative 2 is minus 6. Collecting like terms, we've got two terms with x, so we're going to say 2x squared minus 4x plus 3x is just minus x, and minus 6. And this, guys, expanding and simplifying the quadratic, 2x squared minus x minus 6 gives you the achieved in this situation. Okay, let's keep going. Question 1b. We've been asked to find the value of x if 3 to the power of x plus 1 equals 81. Okay, so we've got 3 to the power of x plus 1 equals 81. And here, this is a classic MCAT question. The crux of the question is understanding your powers of 3. So we've got 3 to the power of 1 is 1, 3 to the power of 2 is 9, 27, and 3 to the power of 4 is 81. And so in order to solve this, we can actually say 3 to the power of x plus 1 equals not 81, but 3 to the power of 4. And now, knowing our power rules, if the bases are the same, which in this case, the 3's, we can cancel them out and say, because the bases are the same, the powers to which they are raised to must also equal each other. So we've got x plus 1 equals 4, and solving this, you go x equals 3. Okay, just an achieved question, correct solution, no alternative here. The marking schedule does mention can be solved using guess and check methods, but this is how you do it algebraically. Okay, so question 1c, solve this quadratic 3x squared plus 2x minus 8 equals 0. Okay, 3x squared plus 2x minus 8 equals 0. This quadratic is different in the sense that a is greater than 1, and what I mean by that, we saw it earlier, a quadratic is written in the form ax squared plus bx plus c, and here a is greater than 1, right, because it's 3. So we have to solve the quadratic. Well, it makes it a little bit more complicated, right? So my method for doing this is first multiplying a by c. So 3 times negative 8 is negative 24. And so we're looking for two numbers that multiply to negative 24 and add to the b term, which is positive 2. And those two numbers are 6 and negative 4. So we're going to say 3x squared plus, and now we split the b term up into our two numbers, so plus 6x minus 4x. And you'll see we haven't actually changed anything. It's just another way of writing positive 2 minus 8 equals to 0. And now we factorize. We draw a line through the middle, and we factorize the left-hand side, common factor of 3x. And inside the brackets, you've got x plus 2. And factorizing the right-hand side, minus 4 is the common factor, and x plus 2. And you know you're on the right track when your two sets of brackets are the same, and all equals 0. Okay, we can further factorize here. 3x minus 4 becomes a common factor, and x minus 2. Okay, and they equal 0. And because they equal 0, we can say for our first solution, 3x minus 4 equals 0. And x equals, take the 4 to the other side, divide by 3, 4 over 3. Or the second solution for x minus 2 equals 0, meaning x equals 2. Negative 2. Okay, achieved, you're either correct factorizing, so possibly up to this point gets you the achieved. Merit both solutions correct, so x equals to 4/3 and equals to, is this? Yep, okay, I've just made a mistake in here. Okay, yeah, positive 2, right? Just saw the marking schedule there. Positive 2, making our final answer negative 2. Both solutions get you the merit. Okay, let's keep going. D, question 1D. The area of the right-angled triangle is 35 centimeters squared. What is the value of x? Okay, so the first thing, similar to question 1A, we need to establish a formula. So the area of a triangle, any triangle, in this case it's a right-angled triangle, is half base times height. Okay? And we know we've been given the area and we're finding x. Okay? We've also been given, if we see the diagram, we've been given side length in terms of x. So you've got x and 4x plus 6. Back to our equation. If we have the area already, we can substitute that in. So 35 equals half is constant. Base is 4x plus 6. And our height is just x. Okay, so we're going to multiply through, expand our brackets, and solve for x. Our left-hand side remains the same for now, 35, and we can even we'll rewrite. Let's expand the brackets. So 4x plus 6 Okay, just another way of writing this is over 2, and that makes it a lot easier. Multiplying by 2 on both sides, we can say 70 equals, and now we'll expand out brackets. 4x times x is 4x squared, and then plus 6x, okay? Now we can see a quadratic starting to form. Let's take everything to one side, so 0 equals 4x squared. I prefer leaving the x squared term as a positive. 4x squared plus 6x and minus 70. Okay. Once again, we've got a quadratic where the a value is greater than 1. Although we multiplied by 2 earlier to take 35 to 70, we can now take out a common factor of 2 just to make it easier on us. 2x squared plus 3x minus 35. Okay, that's all in brackets, and because 0 divided by 2 is 0, so we can cancel out that 2. Now we've got this quadratic, 2x squared plus 3x minus 35. Once again, we multiply a by c, so 2 times negative 35 is negative 70, meaning we're looking for 2 numbers that multiply to give negative 70, and 2 numbers that add, or the same 2 numbers that add to positive 3. And they are positive 10 and negative 7. Okay, so let's start back here. We've got 2x squared. Once again, we split the b term, so plus 10x minus 7x. Once again, we haven't actually changed anything. Minus 35. Okay. We draw our line down the middle and we factorize left and right. You've got 2x and x plus 5. And for the right hand side, minus 7 is a common factor. And x plus 5, once again, you know you're on the right track when your 2 brackets are the same. And that equals 0. Just bear with me, running out of space here. Where are we? Okay. (2x minus 7 becomes a bracket, and x plus 5 is our common bracket, and they equal 0. Okay, from here, just conscious of room, we can go ahead and say x equals 7 over 2 or negative 5. Okay, now there's one last thing. Because we're working with, we've actually been given this context of a triangle. We're working with side lengths. You can't have side lengths. You can't have negative side lengths, meaning x equals to negative 5 is not a solution. So our only solution here is x equals to 7 over 2 or 3.5. Okay, so your achieved is equation correct by expanding or removal of the factor of 2 from the term of brackets. So up here somewhere. Merit, you've done that. You've also consistent factorization of the quadratic into 2 brackets. So up here possibly is the merit. And excellence, correct solution justified. So 7 over 2 and negative 5, giving them as solutions, would probably only get you the merit. but we've linked back to the context of the question and ruled out -5 as a solution, and that will get us the excellence grade. Okay. Moving on, question 1E. Sophia and Tama's grandmother is a maths teacher. She bought both of them some fidget spinners, but they have to solve a maths problem before she will give the fidget spinners to them. Tama thinks that because he is older, he should get more fidget spinners than Sophia. Okay, that's important. They are told that the number of fidget spinners they each will get relates to this number n. Their grandmother says that the number of fidget spinners that Sophia will get is this number n cubed plus 3 times this number, which can be written as, okay, that expression. Tama will get the number n squared times 2 plus 6 times the number n, right? And that's in word form. They haven't given us a expression for that, or a numerical expression. What value, the question asks, what value could n have so that Tama gets more fidget spinners than Sophia? Okay, so what value of n gives us t is greater than s? We'll say t for Tama and s for Sophia. We have to form some equations here. Okay, we've already been given the equation, the number of fidget spinners for Sophia. It was n cubed plus 3n, and the factorized form was n squared plus 3. Okay. Now for Tama, it says he'll get this number n squared times 2 plus 6 times the number n. Okay. So for Tama, it's 2n squared plus 6 times the number n, so 6n. And even because they made Sophia, they gave Sophia's equation in factorized form, we don't know if it's relevant yet or not. Let's just factorize it. 2n in n plus 3. Okay. So they're saying what values of n, what values could n have so that Tama gets more fidget spinners than Sophia? We're going to use our equation t is greater than s. So this is s and this is t, right? And so we're going to say, let's use our unfactorized expressions. 2n squared plus 6n is greater than n squared, is that n cubed? Yep, n cubed plus 3n. Okay, we don't work with n cubed in MCAT, at least not as far as I can remember. That would be difficult. We can factorize. We can use our factorized forms. With Tama though, it's basically we'll want to cancel out. We'll probably find ourselves a quadratic and solve for n like that. We can't do it with n cubed. We want to use n squared. So like for Sophia, like this equation, right? For Tama, let's go. If we want to cancel out n, okay, let's just do this. 2n, let's use factorized forms and see what happens. 2n, n plus 3 is greater than n squared plus 3. Okay, we can divide by n on both sides. So we've got 2n plus 3 is greater than n squared plus 3. Okay, so we can see our quadratic starting to form. we have to, it feels like we're going around in circles, we have to multiply out tama, so 2n plus 6 is greater than n squared minus 3. And taking everything to one side, let's take everything to the right. Again, I enjoy having the n squared, in this case it's n squared, usually it might be x squared, having that term as a positive. N squared minus 2n, and then minus 3 minus 6 is where are we? This is, yep. Just checking my notes, it's a positive 3. So positive 3 minus 6 is minus 3. Okay. Now this is a pretty straightforward quadratic. Two numbers that multiply to negative 3 and add to negative 2. They will be positive 1 and minus 3. So n plus 1 and n minus 3 is less than or equal to 0. Now this equation is a little bit different in the sense that we're working with an inequality, so we're working with less than instead of equals. The first thing to do is actually graph this. So we've got a parabola here. It's an n squared. Okay, and we've got our two solutions of, because it was n plus 1, our solution would be minus 1, and n minus 3 equals 0 becomes positive 3 as a solution. And we're saying, when is this less than 0? So this line represents 0. When is this parabola less than 0? So we're actually looking for this region here. Okay. Meaning, values for n is minus 1, n is greater than minus 1, and less than 3, right? I hope that's familiar. Or rather, I hope that makes sense to you. Similar to before, we know n can't be negative. Because we're working with physical quantities, right? The fidget spinners. So n can't be negative. So we could even give values of n because it's a pretty small range. N could equal not 0 either, right? It could equal 1 or 2. And that, guys, gets you the excellence. Okay. The marking schedule accepts, they accept the region negative 1, n is less than negative 1, and n is greater than negative 1 or less than 3. Preferably you go n equals 1 or 2, but that's right. Anyway, merit, you've generates simplified quadratic expression ignoring the inequation. So here somewhere will get you the merit. And achieved correctly writing the inequations for both Sophia and Tama. So possibly probably this first step here. Okay. Sweet, that's us for question 1. Let's move on to question 2. So question 2a, we've been given this equation, a equals 9 quarters r squared. Give the equation for r in terms of a. So they want us to make the subject. Let's first just write down our equation. A equals 9 over 4r squared. and we're rearranging for r. So the first thing we can do is multiply by 4 on both sides. You've got 4a, and it cancels out on the right hand side, so just 9r squared. And now let's divide by 9, so we've got 4a over 9 equals r squared. And we've got r squared, but we're looking for just r, so the opposite of squaring is square rooting. So we're going to say r equals the square root of 4a over 9. Okay. This is yep, this works. This will get you achieved. The marking schedule mentions plus or minus as well. Okay, they also say, yeah, you could also, because 4 and 9 are both square numbers, you could say this is 2 over 3 root a. Okay, either of those answers gets you the achieved grade. Okay, moving on to question 2b. A house shaped model is shown in the diagram. The perimeter of the model is 32x minus 7. What is the length of the side labelled AB? And that's this length here. We've been given some side lengths: 4x minus 2, 8x plus 3, 6x plus 5, and 10x plus 1. Okay, and the perimeter, once again, perimeter of the model is 32x minus 7. In order to find length AB, we can use our perimeter equation. So P equals the sum of sides, right, of a shape. So we can say, starting at 4x minus 2 and working clockwise, we've got 4x minus 2 plus 8x plus 3 plus 6x plus 5 plus 10x plus 1, and then plus AB. Okay, and also we've been given, we actually know the perimeter, so that's 32x minus 7. So before we rearrange to find AB, let's collect like terms. So we're going to add all the terms with x in them, so 4x, 8x, 6x, and 10x. And we're going to collect, we're going to add all just the single digits, so -2, 3, 5, and 1. Right? We've still got 32x minus 7 on this left-hand side. Working with the blues first, so 4 plus 8 is 12, plus 6 is 18, plus 10 is 28x, and minus 2 plus 3 is 1, plus 5 is 6, plus 1 is 7. Okay, and plus AB. Now we can simplify this further. Let's take this 28x plus 7 to the left-hand side. So we go 32x minus 7 minus 28x minus 7 equals AB. Once again, collecting like terms, we've got our 32x and 28x. And we've got a minus 7 and another minus 7. So 32 minus 28 is 4x. Minus 7 minus 7, negative 14. And that equals AB. Okay? So you're achieved establishing the relationship including AB. So just our first line of working gets you the achieved. And merit correct simplification of expression. So final answer gets you the merit. Okay, let's keep going. Question 2C, write this expression 2 over x plus 1 plus 3 over x minus 2 as a single fraction. The first thing to do to make it easier for ourselves is just write down our expression. So that's not plus 3 over x minus 2. Okay, and we want to combine these two fractions into a single fraction. I think the easiest way is simply to cross multiply. So we multiply diagonally. So 2 and x minus 2, and we multiply diagonally again. And we're also going to be multiplying our denominators. Okay, so starting at the top left, we've got 2, and I'll even write it out just to understand how this cross multiplication works. Plus and denominators. Let's also keep denominators in factorized form as well, just for the purpose of understanding how this works. Okay, so that's our first fraction. Our second fraction will be x plus 1 and 3. And again, x plus 1, x minus 2. Okay. Now, when adding fractions, when we have the same denominator, we can combine them like that. So let's do that first. At the same time, let's also expand our numerators. So 2x minus 4. And it'll be 3x plus 3. Okay, and that's all over x squared plus x minus 2 is minus x minus 2. Okay, and that, guys, gets you the we still need to collect like terms. I almost forgot. Collecting like terms, so we've got our 2x and our 3x, and our negative 4 and positive 3. So 2 plus 3 is 5x, and then just minus 1. And that's all over x squared minus x minus 2. Okay, so merit for that. Marking schedule says denominator does not need to be expanded, so we could retain this factorized form, but that's right. Either way works. So correct statement with numerator simplified gets you the merit. Achieved correct arrangement for numerator is where you get your achieved. So somewhere around here maybe. Okay. Let's ask for question 2D. 2C rather. Moving on to question 2D. We've been given this equation. We've been asked to solve 8 times 2 to the power of x minus 4 is less than 20. Okay. So writing out our equation, x minus 4 less than 20. Once again, powers of numbers, 2, 3, 4, 5, comes in handy in the MCAT. We know 8 can be written as 2 to the power of 3, and that's exactly what we're going to do. 2 to the power of 3 times 2 to the power of x minus 4 is less than 20. Okay. Now looking at this left-hand side, our bases are the same. We're multiplying, which means we add the indices. So combining this, we've got 2, and then 3 plus x minus 4 is going to leave us with x minus 1. And that's less than 20. And now the question becomes familiar to this question 1b, right, this one. Okay, but now we're working with 2's and powers of 2. Also, it's an inequality, so we're saying less than 20. Okay, so that makes it a little bit difficult. Let's write out the powers of 2. Because we want to transform this right-hand side somehow as well. Okay, 2, 4, 8, 16, 2 to the power of 5 is 32. And if we're saying that our left-hand side is going to be less than 20, let's say it'll be less than, and we're working with whole numbers, right? Okay, no calculators in this exam, remember? So let's say 20 is 2 to the power of 5. It isn't actually, but any whole number for x will be less than 2 to the power of 5 and therefore less than 20 also. Okay? Our left-hand side remains the same. Now, because, same principle as before, bases are the same, which means we can cancel out and just work with the powers. So x minus 4 is less than 5. Okay, and x not x minus 4 anymore, is it? X minus 1. X minus 1, x minus 1. And x is less than 6. Okay? You could have said, just to prove this idea of 2 to the power of 5, you could have said 20 was 2 to the power of 4. And in that case, we would have got x minus 1 we could have said x minus 1 was less than or equal to the power of 4. Meaning x is less than or equal to 5. That's also a valid way of doing it. Okay? So, excellence for this. Merit is you need to do 3 things. 3 of the criteria for achieved to get the merit. So writing 8 is 2 to the power of 3, dividing by 8, so that's another way of doing it. You could have divided by 8, which would make the right hand side 2.5 and working from there. right hand side in index form, so we did that. Combines the indices on the left hand side to their simplest form. We also did that. So merit. Well, this part would definitely be a merit. Possibly as early as this one as well. Okay, you're achieved. Yeah, even just writing 8 is to the power of 3. Gets you the achieved, so up here. Okay, let's keep going. So question 2E, George and Leo are organising 27 people in 2 groups to go to a sports game. The tickets cost $20 for students and $30 for adults. Half of George's group are students. 2/3 of Leo's group are students. The cost of the tickets for the 27 people is $650. And the question asks how many students are in Leo's group. Okay, so there's a lot going on in this question. We have to write out some equations. Okay, let's say, first of all, working in terms of students, we can say half of G, so we'll say G is George and L for Leo. Half of G is students, and we'll say S. Okay, we can even, because we've got a number of variables, we'll just write a key. So G, George, L for Leo, S for students, and A for adults. Okay, so half of G equals S. For Leo, 2/3 of L equals S. Right? Let's also say we know 27 people in total are going, so we could say S plus A equals 27. It might help us, it might not. We could also say, working in terms of money now, 20S plus 30A, because it costs $20 for a student and $30 for an adult, equals the total cost, which is given as $650. Okay. And now, hopefully you're familiar with simultaneous equation. There's almost always a simultaneous equation question in the MCAT. So we can solve this pair of simultaneous equations. We could do elimination, multiplying the S plus A equals 27 equation by either 20 or 30, or even dividing down the 20S plus 30A equation. Let's use the substitution method though. Let's say A equals 27 minus S. Okay, and so for the second equation, we can say 20S plus 30, and now instead of A we say 27 minus S, and this equals 650. This question is a bit complicated in the sense that you're working with big numbers and there's no calculators in the MCAT. But so we have to multiply, or we have to figure out what 30 times 27 is on our own, but it's pretty doable. So 30 times 27, well, 10 times 27 would be 270. Multiply that by 2, 540, and again 810. Okay, and minus 30S, and equals 650. So we want to solve for S. Collecting like terms on the left hand side, it'll be minus 10S equals 650 minus 810 is 100 minus 160. Meaning S equals minus 160 divided by minus 10 is 16. Okay. And if we say A equals 27 minus S, well, we know what S equals, so equals 27 minus 16. Therefore, A equals 11. Okay. So that's the first part. Now we have to go back to our other the other thing that's going on, and that's the division of students and adults within the two groups, George and Leo's groups. Let's work in terms of students, because that's what's happening up here. And let's say, well, we know the number of students, it's 16. Okay, so we could say that half of G plus 2/3 Leo just tidying this up here. 2/3 Leo equals the total number of students, which is 16. Okay. And because we've done our students, now we could work with adults, and we could take the remaining fractions left over would be the adult portions in George and Leo's group. So if half of George's group is students, that means the other half must be adults. So half of G plus, and the same for Leo, if 2/3 of Leo's are students, that means 1/3 of Leo is adults, and the total number of adults is 11. So this is our second pair of simultaneous equations. Luckily here, with fractions it's always a little bit daunting doing the substitution method. Here we're lucky in the sense that we've got half G on with both of our equations, so we can just subtract and we're working in columns, right? So we keep our variables lined up, our L's and our G's and our single digits. Hopefully you're familiar with the elimination method for simultaneous equations. So we're subtracting. Half G minus half G cancels out. 2/3 L minus 1/3 L gives us 1/3 L. And that equals 16 minus 11 is 5. Okay. Solving for L. L equals 15. And that how many students are in Leo's group? So we found the total number of people in Leo's group. Now we need to find the number of students. I was just thinking what the question actually wants us to find. Number of students in Leo's group. Our equation for students in Leo's group is 2/3 L, meaning it's going to be 2/3 of 15 equals the number of students. Okay, so number of students equals 2/3 times 15 is 10. Okay, and this, guys, gets you the excellence grade. Correct solutions of 10 students found using any valid algebraic method. And that's what we've done here. Your merit. Simultaneous equations correctly solved, giving both solutions of A equals 11 and C equals 16. So here is your merit. And achieved, forming the equations, that's what the achieved is all about. So 2 equations correct gets you the achieved. And I think perhaps not the half G equals S and 2/3 L equals S, but maybe these equations here. Okay, they get you achieved. Simply writing them down, forming them, gets you the achieved. Okay, that's us for question 2. Let's move on to question 3. So question 3a, the area of a garden is given by A equals 2 x plus 3xy squared. If x equals 5 and y equals 2, give the area of the garden. So it's a classic substitution question where we've been given values for x and y, and they want us to substitute them in to our area equation. So let's say 2 5 plus 3, and x is 5 again, it's in brackets, y is 2 squared. Okay, so we've got 2 times 5 plus 3 times 5 is 15 times 4, because 2 squared is 4. 15 times 4 is 60. So further simplifying, we've got 2, and inside the brackets it is 65. 2 times 65 equals 130. Okay, correct solution, 130 gets you the achieved. The marking schedule mentions there's no alternative here, so achieved. Okay, question 3b now. Simplify this fraction, 3x squared plus 12x all over x squared minus 16. So we've got 3x squared plus 12x all over x squared minus 16. So we're going to be factorizing here. Looking at the numerator, we've got a common factor of 3x and x plus 4 inside the brackets. The denominator, well, that's x squared plus 16. That's a difference between squares, because x squared is a square number, 16 is a square number, and they're being subtracted. Another way of writing this is x squared plus 0x minus 16. And so our principle, it's still a quadratic, right? Our principles for factorizing haven't changed. We're looking for 2 numbers that multiply to give negative 16 and add to 0. They are positive 4 and negative 4. Okay, it helps to know of the difference between squares and be able to recognize it. You might have, for example, x squared minus 9 or x squared minus 64. You know, first case it will be plus 3 minus 3, and for the second one it will be plus 8 minus 8. So we've got x plus 4 and x minus 4. And we can see we've got 2 sets of factors that are the same, meaning we can cancel them out. So we cancel out x plus 4, and we're left with 3x over x minus 4. And that, guys, correct solution gets you the merit grade. Achieved correct factorizing of numerator or denominator. So probably this step here gets you the achieved. Okay. Moving on to question C. Georgia is designing a new logo for her sports club made up of 2 circles. Okay. She draws one logo on top of another as shown in the diagram. So that's our diagram. The total height of the 2 circles is always 20 centimeters. Okay, so question CI. Georgia is exploring what happens to the total circumference of the 2 circles when the radius of one increases and the other decreases. Show that the total of the 2 circumferences of the circles is 20 pi centimeters. Remembering that circumference equals 2 pi r. Okay, so we're trying to show the total of the 2 circumferences of the circles is 20 pi. So total of the 2 circumferences, meaning circumference of, let's call this circle 1 and this circle 2. Circumference of 1 plus circumference of 2, and we have to show that this will equal 20 pi. Remembering that C equals to 2 pi r. Okay, so I think we can say for the first circle, okay, basically expanding on this equation here, this top one, we've got 2 pi. Now we have to find a way to denote the radius of each circle. So 2 pi r, let's say 1 because that's circle 1, plus 2 pi r 2. Okay, and now we can say, we can factor out 2 pi because that's a common factor, 2 pi, and we're left with r1 plus r2. Okay, and we know, that's in brackets, and we know that, looking back at the question, the total height of the 2 circles is always 20 centimeters. Okay, but, and if we draw this again, this is where it just takes a little bit of knowledge and a little bit of play with the 2 radiuses. Okay, so this is a radius, and this is a radius. Let's just draw this better. Okay, and we've also got a radius here and a radius here. And you notice I've drawn them stacked on top of each other, and the whole height is 20. Okay. In our equation here, we've got r1 plus r2. Now r1 plus r2, forgetting our little diagram, because keeping in mind that the 2 circles are increasing and decreasing respectively, right? So we don't actually know in terms of scale how big or small they are at any one time. But r1 plus r2 must equal not 20, but it equals 10. It's half, because the total height is the 2 diameters, which is 4r. Okay, radius is half of the diameter. 4r equals 20, or rather we could say 2r1 plus 2r2 equals 20. Okay, this is the idea. r1 plus r2 equals 10. Okay, So we can say, therefore, 2 pi, and substituting in, instead of R1 plus R2, we can say 10. So, total circumference, 2 pi times 10, well, we can multiply 2 and 10, 20 pi. Okay, and this is actually an excellence grade. The actual working, pretty simple, but it's that abstract thinking with the radiuses and the diameters and the height, and that's why it's excellence here. So correct proof using generalized algebra to complete the show question, that gives you excellence. Merit, numerical calculation using 2 different pairs of radii or diameters, or 2 correct procedures from the achieved in processing to a generalized solution. I think merit would somewhere around here, or perhaps this discussion up here would help you get you the merit. Achieved, the relationship given for radii or diameter of the 2 circles, generalized, relationship factorized, consistent solutions are okay. The achieved is a little bit ambiguous. Let's just say the achieved is forming this equation here. Chances are that if you did that, you'd probably get into the further workings as well. Okay, moving on to question 3CII. Give the equation for the difference in areas of the 2 circles. Give your answer in the simple form, remembering A equals pi r squared. So difference in area. Meaning area of the big circle. So we could call it, that was our second circle. So area of the second circle minus the area of the smaller one, which is, we said that was number 1. Okay? And similar to the way we used the circumference equation before, we're just going to use the equation for area, A equals pi r squared, and we're just going to use that. Okay, so looking at the our number 2 circle, its area would be pi r2 squared minus area for the for our smaller circle, that would be pi r1 squared. Okay, and so we could say pi r2 squared minus pi, and now it gets difficult. It gets difficult to understand where to make progress. This R1, well, let's look at our thing from before. R1 plus R2 equals 10. That was crucial, right? We could rearrange and say R1 equals 10 minus R2. Okay, we substitute that into the formula, 10 minus R2. It's just a way of converting the R1 to R2 to eliminate variables. Okay, and the whole thing is squared, right? Okay, continuing on, R2 squared minus pi, and we're squaring the numbers. Formula for squaring, well, let's write it out, R2 and our second bracket rather. Okay, r2 squared minus pi, so that's going to be 100, and then our b term is 2ab, which is 2ab 20, minus 20r minus 20r2, and then our c term is positive r2 squared, and it's all being divided by pi, multiplied by pi still. Let's multiply through by pi. Let's expand those brackets. Okay, so minus 100 pi, and we'll say positive 20 pi r2 and minus r2 squared pi. Okay, we're making progress. And now, in fact, we can start to cancel things out. So pi r squared here and pi r squared here means they cancel out. And we're left with 20 pi r2 minus 100 pi. Okay. And I think, that would actually get you, that's the correct relationship, right? That gets you the excellence grade. You could say, you could factorize even further and say 20 pi r, and we can just drop the r now. We're only working with one radius, we don't have two of them. R minus 5, because 100 over 5 is 100 over 20 equals 5. Okay, either of these two equations gets you the excellence here. Okay, your merit, 2 or more of procedures for use, so forming the equation, consistently expanding the quadratic, simplifying, factorizing, all the rest of it. Merit, the earliest merit you could get is here, I believe, and achieved even forming the equation, so let's say here is the achieved. Okay, question D. For what values of x will 5 times 5 to the power of 3x, I believe that is, equal 5 to the power of minus 2x squared? So let's say 5 times 3x, 5 to the power of 3x equals 5 minus 2x squared. Okay. Now we can go ahead and combine terms on the left-hand side, remembering that this first 5 is raised to the invisible power of 1. We're multiplying, which means we can add indices, and so we've got 5 to the power of 3x plus 1, and that equals 5 to the power of minus 2x squared. And our bases are the same, they equal each other, meaning they can cancel out, and we can equate 3x plus 1 and minus 2x squared. Okay, we can see a quadratic starting to form. Let's bring everything to one side. We've got 2x squared plus 3x plus 1 equals 0. Multiplying A and C terms, 2 times 1 is 2. We're looking for two numbers that multiply to give 2 and add to positive 3, and they are 2 and 1. So 2x squared plus 2x. Remember, we changed the b term into its respective x parts, so 2x plus x. We haven't actually altered the equation in any way, and that all equals 0. We draw our line, we split the quadratic, and we factorise the left-hand side, 2x. Inside the brackets you've got x plus 1. And on the right-hand side it's plus 1 is a common factor, and x plus 1. Okay, and that equals 0. So 2x plus 1 becomes a factor, and x plus 1 the other factor, and they equal 0. So looking at our first solution for x, 2x plus 1 equals 0, meaning x equals minus 1 over 2. 1 over 2. And if x plus 1 equals 0, that means x equals to negative 1. Okay, correct solutions, both solutions, gets you the excellence grade. Your merit comes from procedures for achieved, so 2 procedures for achieved, so simplifying indices on the left hand side and generating the quadratic equation from powers of 5. So here is probably your merit. Achieved, simplifying indices, perhaps even as early as this step gets you the achieved. Okay, and that is us for the paper. Thank you all for watching. Any questions, comments, feel free to drop them below. Cheers.